First suggestion, maybe you would like to get together more, so to sit in one group or to feel like at home, or if not. Today we have a discussion, a very broad one. The topic is new technologies, and we could start discussing it today and end up 2 weeks later. Still, we have 1 hour, so we have to be quick. We will start with a few discussion questions, and later on we will go on with audience questions. If there are anybody watching us online, you are also free to submit your questions, and we will try to address them to our participants. So it's a great honor for me to introduce the participants. First of all, I'm Vytautas, I will be moderating, and we have director and professor of this beautiful facility, Center for Physical Sciences and Technology, Professor Gintaras Valušis. We have a guest from Technical University of Copenhagen, Technical University of Denmark, Peter Japsen. Also specializing in ultra-fast terahertz spectroscopy. We have Augustinas Vizbaras, co-founder of Brolis Semiconductors, Vilnius University alumni, and we have Audrius Alkauskas, theoretical physicist, theoretical solid-state physicist, also working here, and researcher in this Center for Physical Sciences and Technology. So the first question I would like to ask director of this center. This center contains many institutes, Institute of Chemistry, Physics, Textile, and various departments ranging from environmental physics, nuclear physics, molecular compounds, and so on. So as we start our discussion about new technologies, I would like to ask you to tell us a story. A science fiction story that would sound like a science fiction today, but maybe it will become true in like 10 or 20 years. So for example, if we have a guy or girl waking up in the morning and traveling to the airport from Copenhagen to Vilnius, and what is she wearing? What is the clothes? What technologies are in clothes? What technologies are in her or his smartphone? What detectors does she or he face at the airport? And what is the means of traveling? How do planes look in 10 years or 20, from your perspective?
Yeah, it's a good question. I mean, it's not so easy to predict something in this a particularly non-linear world, but I would say that probably textile will be smart. No, everything seems to be smart except the refrigerator. But probably, I would say that maybe optics could be something like very good tool to make something smart. In contact way, no contact at all. So maybe this lady which traveling from Vilnius to Copenhagen or vice versa, probably will know that mobile phone will let her know where he is exactly at the same time, what the kind of gases that comes from her mouth. Probably if she is maybe wants to take some drugs just to repair her health, I don't know. And probably what she was wearing, materials probably also will be filled with many kind of sensors, allowing to control environment in all possible ways, including gas or maybe temperature. I don't know what's its good approach. Probably, I'm not sure whether it makes her happy, but in principle, I think that things should be very small and should be digital, and they try to communicate with each other. Probably mobile phone will be this tool which allows you to see a lot of things which are usually invisible by your eyes or can be sensed by your nose, something like that, probably. I'm not Arthur Clarke, which can predict something very smart.
So we came to the part of the airports, and I would like to ask Peter, you are specialist of terahertz imaging. So what can people see now, and what they are going to see and sense at the facilities of the airport? What is your speculation regarding next 10 or 20 years?
I think that if we start with what's possible nowadays, now we have these airport scanners that work with microwaves. We of course also have the standard X-ray scanners that check our luggage. And some airports have X-ray scanners that actually check us also. These backscatter X-ray images. But the millimeter wave ones are the new ones. And the one where we can see that there has been a very big development for the last 5 to 10 years or something. I recall I started thinking about this maybe 10 years ago, and at that time it was actually science fiction. And then at some point, some big companies, like there's a company called L3 that sells these scanners that we have nowadays, or at least that are placed somewhere in quite a lot of airports. And these scanners work in a way that we cannot see it as the customers, so to speak, or as the victims. We only see a pictogram of ourselves where we can see, oh, the guy has something in his pocket or he's sweating on his back or something, right? But those behind the scenes, those machines can actually see the brand of your underwear. I mean, they make extremely detailed images already now. And I think this is something that will continue, that will be refined in the future, but I think this is actually already pretty good. And what can be refined on it is that it can be made into a system that doesn't work like a portal. It just surveys an area. This could be, I think that's a reasonable prediction that could happen. It's difficult, but it's sort of, from a physical point of view, it's feasible, at least. Many science fiction things are not. But I think what will change is the amount of things that can be sensed. You talked about it already, gas sensors and so on. I think sensing the environment around persons will be one of the things that is coming up. We see it in specialized environments now that you can check your exhale air and so on, but I think this will become more prominent, and this will require a lot of development of the mid-IR that I know that some of you guys are working on. But I think more complete knowledge about who's going in and out will be what we will see in the coming 10, 20 years. And we will still see dogs running around and sniffing, because that works wonderful also.
So Augustinos, we came to, in my mind, came to a crucial question. There are many different technologies developed in the lab, but at the end, some of them are applied and some are not. What are the recipes of success of these technologies? How does it sell? What ingredients does it have, and does a coincidence play a role, or exact timing of releasing contribute to the net success of some new technology to be applied in the everyday life, not only in some specific facilities or labs?
My understanding that there's definitely much more than one factor that plays a role, and timing is one of them. First of all, it has to match user experience, so to say. So that means, it has to offer an advantage that is not there, and that the user can immediately notice that advantage, right? So if we deploy some sensors, it has to provide useful data. Because if you look at the wearables today, so we have a lot of so-called smartwatches, but they are not smart at all. They don't really give you a lot of data, or useful data, let's put it that. They count your steps, they do whatever you want. But so far, as of today, that data is not much of use, or let's put it that way, those smartwatches are not that smart yet. However, I definitely see that there will be a big change that can provide what I say like a revolution in that sense, that there are a lot of sensor technologies that could provide us really, really valuable data, that, let's say, personalized health data. That's one of the big fields where I see a huge, huge application domain, let's put it that way, that could really inflict big changes in our society. That could really change the structure, let's say, of how our healthcare systems work, how much it costs, right, and how good it functions in terms of preventing bad things happening. So I see that. So it's also related to a lot of remote sensing. To really get those technologies deployed, there are several things that have to match. So as I said, it has to be useful, Second, it has to be cheap to be deployed. I mean, you can have greatest technology in the world, but if it's too expensive or if it's not scalable, then it will not be deployed, or it will only be deployed as a portal technology. That's what we see in the, let's say, airports. So I mean, and that's not easy. I mean, and it can take 20 to 30 years to actually to happen. And I think you'll get an excellent talk tomorrow morning by Roll Bartz about silicon photonics. I see that's like a portal to make photonic systems really small, really scalable, really, let's say, cheap, to enable new change. I mean, that field has been known for many, many years, but still today it's not really deployed to mass market. So, I mean, so sometimes that future that we think, I think it's not really science fiction, or the change doesn't happen so fast. I mean, because everything has to match. You have to be able to manufacture, it has to be cheap enough, and it has to be useful. So it's kind of these things are always there, and it's a very inert system, let's put it that way. Industry in general is a very inert system. They don't want to change anything. And so to provide a disruptive change is not easy. It's really not easy, but it has to come from the lab. There is no, I don't see a big chance that it would come from the big guys. Typically they are, focused on their, let's say, share price in the market if there's a public company. But in the lab, you're free to develop really disruptive technology or something out of the box and so on. So it has to come from there. And just to finish off, I hope that planes, in 20 years from now, will have much more legroom than today. So I hope that there will be no economy class. Yeah. Yeah, I think this is something that has not changed, right, over the last 100 years.
So it seems we are going to have more and more sensors, and we will need more and more computing power to analyze the data and do it instantaneously on the fly. So I wanted to ask Audrius, you are a specialist of quantum computing, and maybe nowadays it's obvious that quantum computer will not be the same computer as we have it now with programming and algorithms as we understand it now. But in general, do you see prospects of quantum computing used in data science, or in general, how do you think computing will change during the next 10 or 20 years?
Can I answer more broadly?
Sure.
Because it's a very specific question.
Sure.
As they told, I am a theorist, so I was thinking more about something more general to start. So first of all, is it worth at all talking about new technologies? That's what I mean. We have to answer the question why. So there is this paradox about development of society, that a poor society works for the benefit of a richer society. So, I mean, in general, you would think this makes no sense. If a poor country works so that the richer country lives better. So imagine our parents who really lived poorer lives, and they had less food and smaller flats and so on. They worked so that we live a better life. And we work for the future society who will be better than us. So this is a paradox, that we as poorer people work for the benefit of the richer people that will live in the future. And you have to first answer the question whether it makes sense, and this is the same question whether it's worth raising children. Because you don't actually, when you raise children, you invest in the future, and they will give back to their children and so on. So first we have to answer the question that yes, it's worth caring about technologies. And in general, if you try to think what technologies do we need, so everybody in general strives for happiness. And if you try to think what will make me happy right now, I mean, who thinks that I need more time to be more happy? I don't have enough time, I always rush. Who would be happier with a little bit more time? So you see, time is the most, or with more socializing and so on. So if you think about technologies, you have to think what people need. So when you think about more time, so what could save me time? So for example, I like cooking on the weekends, but I don't like cooking every day. It takes a lot of time. So if you would go home and there would be fresh products and a robot would cook a meal and you have a fresh meal, and then you would not spend half an hour cooking. And people like clean houses. And if there would be a robot, would be a little bit smarter than the robots are now, and you would have a clean house, clean window, and so on. So if you think about happiness, so you would immediately see that robotics and robots will be a very big contribution to the future of society. It will not solve all the problems of happiness. Sometimes, it's a mental choice. But this is one point of happiness. And I would like then to bring back then talking about robots. But then I want, if you ask about quantum computing, so there is a very long chain to happiness here. So everything in the future will be powered by something, right? So first we want to be secure, happy, we want to create and live normal lives. Everything will be powered by energy. So we have to make step towards energy, and this is also, I thought a bit, what are really the biggest problems. And if you talk now, it would be also interesting to come back to energy, but if we talk about computing in general, so it will help solving the problem specifically of energy, in my opinion. So for example, how we will generate energy. There are many problems that are left unsolved and put away. For example, we have a lot of energy coming from the sun. There is something called like photocatalytic water splitting. So you have a photocatalyst, you have water, you have sun, and it splits water and it produces hydrogen. Where to store this hydrogen, how to use it. Or also there is something called solar fuels. So for example, solar reduction of carbon dioxide, you make carbon monoxide so that you can burn it, or you can produce from CO2 methane. And in principle it works. There are simply no materials that does the job. So what do we do now? Now we take a material, we translate the quantum nature of the material into a classical language, and we write everything in terms of classical we understand, in terms of wave function and everything, and we'll try to really model the behavior of this material. And this scales exponentially with the size of the material. In principle, if the system is twice larger, it does not take twice longer to evolve. So, it takes the same time to evolve. This bottle, it lives 1 second as long as I live 1 second. So, but if you want to describe it mathematically in terms of classical language, you would need much more time to describe me on a computer. So instead of, you see what I mean? In principle, so you should be able to describe a large, complicated system in the same way as a small system. So in principle, a very specific application of a quantum computer would be quantum simulator, that you would map the behavior of the system that is very, very small and that you cannot measure on something touchable that you can measure, and this large system would behave exactly the same way. It will have the same Hamiltonian, if you will, as the small system. And instead of, you could monitor its behavior, and it will really facilitate the development of new materials, testing new concepts, and so on. So if you ask about computing and quantum computing, so its biggest applications will actually be for science, for simulating materials. It will not take away our bread, but it will just transfer, it will enable us to predict things better. So you see, also I touched robotics, and then energy, and then computing. Computing is always supplementary. So for example, how many of you know how much computers come into your daily life, large computers? You even don't think about it. It fly planes. They are modeled by computers. If you take drugs and you have a rare disease, the interaction of drugs with bacteria is modeled by computers. You don't think about it. So computing is everywhere, but it doesn't affect us directly. It doesn't affect us directly, so you would not see immediate reaction, immediate feedback, as let's say with a robot, that you can take 5 robots and go hiking into a forest. Computing is somewhere there, but it's not immediate in our immediate environment.
Thank you. Do we have any questions? Especially, please.
Okay, it's for you, Aldris. Because you talked about the robots cooking our food and everything, I think there is some happiness in doing some things manually. And we've witnessed that, for example, social media and smartphones and that like technology we have in our daily lives has changed our social interactions and has done some things that are arguably not good. Do you think there is a line in the sand to be drawn when it comes to innovation? For example, there was this question about, do we want to know if we are going to have some kind of incurable disease? Because technology in a few years is going to let us know such things. Do we need somewhere to put a stop to innovation doing things that are not so good to us?
Thank you.
Yes. That's a tricky point, and of course we have to be very careful. So there are certain cases where robots would help. For example, if you have aging parents, and all of us will have aging parents, and even parents themselves say, don't pay attention to me, so I'm okay. It's too expensive to hire a person who would help. And instead, you would devote some attention to your parent from time to time, as much as you can, so that you don't become insane yourself, but the rest, all the dirty job will be done by a robot. So this is okay. Everybody agrees this is okay. Maybe taking care of children is another story. Diseases, curable, incurable, that's also a very subtle line, because some diseases that were thought to be incurable are actually curable. So I was thinking, inspired by Augustinus, about detection, sensors detecting early warning signs. If you exhale something and there's something bad in the air you exhale, and or if you lie actually on the bed, and actually the bed has a sensor that says, aha, you have first signs of arrhythmia, so your heart is arrhythmic, you can get it treated. Or even in the future, you might think there is a computer observing you, and you say, aha, I mean, by statistics, you have forgotten, you're already 65, and by statistics, you have forgotten so and so many things. You have first signs of Alzheimer's. I mean, some people might be shocked by that, but some people will say, okay, thanks very much, I will go and have a treatment. So it has to be decided case by case. Of course, if, I don't know, even if people would know they would die tomorrow, they would probably live today more fully.
Do you have anything to add?
I think it's a super important point. We can already see it now. We talked about how smart or not smart watches are and so on. But one thing it's smart for is to collect data for someone, right? Not for ourselves maybe, but if something is free, then we are the product, right? So I think it's one thing that we and you all should think about in the future. How do we manage all this data, all these possibilities that can be good or bad? I think this will be equally important as the technological innovations. Now we have invented a new thing. Now Google comes out with a new way of helping us. But are they helping us? Or are they helping themselves? Right? I'm not saying anything against Google here specifically. Don't think about it like that. But I think we should think about, as part of going into the future, is what is it really that we want to use the future for? There's a lot of horror scientific movies about how horrible the future will be. It's all bleak and Blade Runner style, right? We don't want that, and it's only us who can steer it, I think.
I'd like to just shortly add to what Audrus also said, or what Peter said here. I think it's sometimes maybe we are polarizing too much the future. It's either black or white, right? I think you should think about that. Also, early warning sensors that you would carry every day, right, would provide completely new insights into your life and really personalized data about what changes. I mean, today you just go to your doctor when you're already bad, right? And that's typically a problem, and that's why you associate, oh, I don't want to know that I have that disease. But it's because you went to a doctor already when you had symptoms, right? And with early warning preventive systems, and then the entire healthcare systems would be directed to actually help you live a better life. So actually I bet that if data is controlled correctly, you would see a big improvement in your life quality. In fact, you wouldn't worry about it anymore because you would get advice or prescription of drugs or some other things at a very early stage, and this would allow you to live longer, happier, healthier, and so on. So I think this would really change the life. And especially, I think today it's kind of, the healthcare system is really, I would say, not very well developed in a sense that it's extremely costly and it's not going cheaper. It's getting more and more expensive, even though we are pouring so much money into it, right? You take US, even Europe as well. Although Europe, I believe, has a better system, but it's getting more and more expensive, so it costs us more. But do we get better, right? I mean, it's kind of an open question, and I think that needs a change, and I hope that this will provide a change.
So, yeah, sure.
I would continue probably, but I mean, the future will be gray. I mean, as there is no very distinct colors, but everything depends on the reference system. So, I mean, human beings does not change in many, many years. I mean, if you look at drama from ancient time to now time, I mean, the same problems, be or not to be, is I mean, so important question, and it should never be, I mean, be solved in a proper way. So, but I think that, I don't know whether computer will help just to find a good reference system and to find good attitude to all technologies we're getting around, because now it's difficult to imagine our life without mobile phone, for instance. It's so. But if you come back 10 years, or even 20 years, internet is just only racing. So and it means that technology which have on semiconductor chip is so. I mean, limits of Moore's law, and it's now we can finish faster systems. But the problem is about data collection that Peter mentioned. I mean, there is no clear vision how many data and which data we will need, because everything depends on your reference system. So it seems to me that all this collection, we can a lot of data, and we need a huge amount of knowledge to understand which data are important or which can be used for. I think that there's all the time is some big uncertainty, and it depends on our brains, and probably system has no any relations with happiness, because happiness is totally out of science fiction. Probably it's another literature stories. I don't know.
Totally. I mean, antibiotics bring back happiness quicker.
Yeah. We have questions?
According to the discussion, you mentioned sensors and robots. So I would like to ask one specific question according to terahertz field. I can imagine that when beam steering will be present, we will have very fast data exchange between different devices. But do you imagine terahertz imaging systems in robots? Where could they be used? Maybe just how do you see that?
Probably Peter, can you start?
One can imagine a lot of things, but I think the most realistic is that if a robot should have a terahertz imaging system, it's a robot that has a special purpose. It could be a robot that is used to sort boxes with different contents, and the boxes, we know in advance that they are transparent to terahertz radiation and so on, so that can do a specific job there. Whether a robot, let's say a robot that works at home, cooking food and so on, whether that would need a terahertz sensor, I don't think so, but don't let yourself limit by what I think. I think that's a sensor like any other sensor. It should sense something. And if there's a specific sort of interaction between light and matter that calls for terahertz waves to do so, then it will be used. There's no doubt about that. But the question is, I think the question could be, what are the relevant things that a robot could do that would need such a vision? And because there are many things, I mean, the terahertz field has evolved, as we know it now, at least over the last 25, 30 years. And there has been, each year there has been a proposal about, with this terahertz imaging technology, we will solve all problems. this is what was, I found a paper from 1975 where they made with a gas suit, with a gas terrorist laser, they made images of a gun hidden inside a book. And they wrote in that paper that this will have great implications in the near future in safety and security and blah, blah, blah. And then whenever people submit proposals nowadays, 30 years later, the same sentence, more or less, is written in the proposal. And so this is one of the things that terahertz may not be the right way to do that thing, even though a lot of people in the field hope for it. Because there are other ways of finding guns in books that already works, right? So it's a matter of if you have a need for building, at this time at least, expensive sensor into a thing, it should solve a problem that cannot be solved by cheaper means. So once that pops up, that problem, then we are there. I'm not sure if that answered the question, but...
So, Gintaras, could you add more about the communication part?
I don't know. I mean, it's interesting, by the way, point. In fact, I have heard that in one of the Japanese labs, there's already have terahertz television, probably, but it's an amazing field. But the problem is the water, which we have around. That's a big obstacle for terahertz communications. It means, from one side, it's good because you can make safe system which operates in this area, for instance, and nobody comes, just no radiation come out. That is okay. But in principle, there's a lot of challenging problems to that, and probably there is no big needs to have so huge amount of data to send exactly by terahertz waves. That's the point. As for applications, as Peter already said, I mean, imaging was so promising so many years, and it was applied for many things like in medicine as well. So, but in principle, there is no quite clear question what the technology has huge advantages over others. So, in principle, skin cancer detection, or if you have damaged your skin by other means, it seems that terminal can make a profile, so how deep is affection of, but in still you need additional techniques to have correlation, because this technology alone cannot be as the most powerful tool currently. Probably it's promising, but it's still under evolution. But what is important, I mean, for applications, detector technology raised so high level in room temperature with unbelievable numbers now. If you look at, for instance, 20 years ago, usually we look at the bolometers or intermonite bolometers saying, okay, we have NEP, something like 100, it was amazing numbers. Now we have at room temperatures like 10 picowatts in NEP scale, so it's like world record. It's very difficult to overcome. But they are so sensitive and technology is so beautiful. Even CMOS technology, which we have in mobile phone, works perfectly for terahertz detection at room temperature. It's amazing because you just make your own chip with very small money and no big technology needed for that. Only bright brains and good software.
Do you have any audience question? Oh, yeah.
What do you think about the feature of the most widely spread technology that the technology that is most widely spread is almost evolutionary adapted to humans, that they use humans to spread them? What do I mean by this? That the smartphone spread not because it's a better way to communicate, well, maybe it is, but it uses, you don't really need to advertise smartphones anymore. People by themselves are keen to get newer smartphones just because it's new. And you don't really need to propagate it, it propagates itself. What do you think about this feature of technology?
I can give my answer. I think this is what we call user experience. So, and typically this is the best way to illustrate. That means that smartphones provide something useful. If they wouldn't be useful, people just would stop using them immediately. And I think for industry, it's always the hardest challenge to actually find out what will the users need, and will they like it, and will they find it useful. So a lot of technologies, fall out whenever every iPhone, every Samsung, every, LG and so on, they contain a huge lot of sensors and so on that come in with every new, let's say, addition. But as you will notice, if you would track back, some of these just don't live long because they just users don't find them useful. So, and only the features that are really useful, that provide some useful data or whatever functions that everyone likes, then these stay, and then they just try to build on that. So I think it's I kind of like that way, because then, it's much better to find out what's useful, what people can do it, and sometimes it's, like really user experience, and especially widespread, provides completely new ideas for the labs, for the industry to, give guidelines what technology to create, because, in the lab, it's very hard to simulate what a human being will like, right, and what will be useful and so on. If you give it there, it's a perfect test system, right? You give it millions and millions of users and so on, so it's perfect statistics, and it's literally for free, let's put it that way.
Can I contradict a little bit? I don't completely agree. I agree from the point of view of a company that produces this technology, but I don't agree from the point of view of society. I think what he has is something different. Sometimes technology companies can really tap into weaknesses of people, and people get hooked. And why they get hooked, I don't know if you read the book Shallowness, and this is, I think smartphones really tapped into very early experiences of people. So this is the essence of this book. So before, we used to multitask. So a woman would just make some food, that would take care of the baby, would look after whether there is a tiger running, and so on. So we would multitask. And creation as itself, creativity started only when people were isolated in, let's say, monastery cells where you were completely safe. You can really follow the book and you can really focus on one thing and one thing only, where this biggest breakthrough in the creativity of people came from. And now with the smartphone, so actually we are back to our actually normal state of multitasking. And that's why we are hooked on it, because it's so natural for us. It's difficult to focus. Focusing was artificial, but it was very needed for creativity. So I think it's a passing phase. So it's the same like with anything, the new inventions always bring something new, but then after some time, people understand that some of it is good, some of it is bad. So at some point, parents and people will understand they became less creative. They became less creative because they were back to this primitive multitasking stage that you have to do all the things at once, and they start to limit ourselves. So they will start increasingly using only those properties of the smartphone that are useful. And it's a training. So whoever will have the ability to focus on one thing will win in this survival race. Because I mean, if you're in a conference and you don't look at your smartphone, and you focus on what the speaker is talking, you are really winning in this competition, in my opinion. So the same with social networks. I mean, don't forget it's only 15 years old. They are barely into their third decade. And with time, they will change. More people are unhappy than happy with social networks because there's too much information. But you will start to filter only information. So going after weaknesses of people can be a temporary solution. Let's say also putting heroin into something. But with time, people will start to really decipher, and they take what's useful. And so, but it can be a strategy, working on weaknesses of people, what people will get hooked on. But with time, they will also be smart, I think, from the point of view of the user.
So in your opinion, is it possible that there exists a parallel universe of humankind as developed as we are now, which didn't have smartphones or other technology introduced at exact time, satisfying exact needs? I mean, do we have a parallel universe where people do not have smartphones?
I mean, come on, this is an answer like Stephen Hawking, some joker, I think, who was it? John Oliver asked Stephen Hawking, is there a parallel universe where I'm smarter than you? And Stephen Hawking said, yes, there is also a parallel universe where your jokes are funny. I don't understand the question.
May maybe, but I think that anyway parallel worlds exist because it's virtual networks. Just as telling, is stealing your real time. That's a problem, I think, because we're living partly in the social networks, partly in the Google search or something like that. But it costs your real time. So I think that there is some limit. I think to limit yourself to be in real life instead of virtual networks. So that I think. So there's no problem. I think that the question of time is not good in principle. It's ill-posted, ill-posted problem, because a question of time is a question of priority. It doesn't matter. Computer or robot doesn't help you in this. So I think that simply we should limit ourselves and to define good priorities and reasonable priorities.
We have a question there. Also, maybe we have a question from internet. Can you check?
All right, I'm going to jump back away from the social aspect of things. I've always been curious how much you think maybe the role of biomolecules would be in making systems. For example, you have photovoltaics. People are thinking of making hybrid photovoltaics with some sort of biomolecules inside of it. I've seen people made nanotubes with light harvesting systems. What use could that possibly be? Do you think this trend is a positive direction? Is there a future?
So maybe interest, does Department of Molecular Compound Physics already do that?
I think that it's modern trend just to find a good, effective, modern way to make produce solar cells. To be honest, I'm still very conservative in this. I still believe that silicon is an option still for solar cells because of stability or something like that. But for scientific point of view, I think this molecular, what we have in plastic lasing, if you look at the papers which were running on light emitters based on organic stuff, they're trying to get lasing from plastic pieces. So it means there is LEDs are all working. So maybe I don't know how it's useful, but scientific challenge is extremely nice. I think that all the stuff which was oriented to the purely applied aims like solar cells or effective solar cells from using molecular stuff, it's amazing field of science. First of all, I think nobody knows how much science, how much data obtained from this field will be applied directly. But all the search is beautiful scientific journey, and it's attractive and challenging. What makes our life as scientists very beautiful and not boring, I would say.
Yeah, maybe another comment on it. I agree. But I think one of the interesting things about these biomimicking processes people are trying to study is to make them long-lived. You can find some biomolecule that does something fantastic. It gets you into nature, but the cell is dead the next day, right? But that doesn't matter. You publish, so it's fine. But once it's something that has to work, then I think the problem becomes much more biological than one should think at first, because all biomolecules in our own bodies, they die the whole time, and they get replaced. There are systems that repair and so on. So if one wants to use this, use inspiration from biology, one should think about how can we make it something that works over a long time. Do we have repair mechanisms that make the solar cell come to life again once the light-absorbing biomolecules have bleached? Can we work on such questions? I think that might be possible. We are talking about the future here, so we don't have to, solve it like next month. So I think that's a very interesting avenue to think about, also for the sort of next generation of sciences. How much inspiration can we pull out of our own bodies, of trees, of whatever living organisms around us? Can we mimic that in a way that works in a machine?
And still we have to be patient, because 30 years ago in grant application, scientists used to write that we will come up with some paint, that we will take a paint bucket, just paint it on the wall, attach 2 wires, and we will have a solar cell. And I see that in many grant applications, the same sentence still goes on. So, Audrus,
Peter,
would
I
like
also
to
wanted
answer
to comment on this. Let's not forget that the science of energy, it's not just the science, material science or engineering. It's also economical science. So it's the entire system. So I read a few reviews a few years ago that, for example, we don't have to just to think that you would put a solar cell and it works for your entire life. So people who are in the organic solar cell business, they perfectly understand that these solar cells will not be as stable. But if you calculate, for example, stability lasts for 3 years, actually it makes physical sense for bigger towns, bigger cities. If there is a company that really sells the solar cells, you essentially rent them. And every 3 years, the company renews the solar cells because it's so cheap. And in that way, you don't have essentially the same solar cell, the same material, but it's constantly renewed because it's so cheap. And in that way, it can compete with all the technologies. So people are smart. They want to make money, and they perfectly understand the material science issues, but also there are economical solutions. But then, for example, it can work only in an area which very large population density. So the science of energy is the science that encompasses a lot of aspects, and sometimes you can lose on one aspect but win on the other.
I think we have a question from
We have a couple
viewers.
of questions from internet. First of all, Emilius Vanagas wants to know if terahertz lasers are already created, like a working device, or are they still under development or theory thing?
Which ones? Terahertz what?
Lasers, terahertz lasers.
Yeah, surely. There are many types of terahertz lasers already today. There are actually terahertz lasers that has been operating since when, the 60s, 70s at least. Big gas lasers around the size of a couple of those loudspeakers or something.
2 meters.
Yeah, like big old school lasers that is a gas that is pumped by some light and so on. But in terms of, let's say, more modern devices that can be sort of taken around, we have the quantum cascade lasers that are in the terahertz range, in the high terahertz range, I would say. They are pushing. There are even schemes for bringing them to the low terahertz range also, or some variation of them. So there are certainly terahertz lasers around. And on top of that, we have all the terahertz sources that are based on I would call it normal lasers, but then the systems are becoming less compact, less easy to commercialize.
I mean, if somebody wants to see this old gaze lasers, we have something like in our lab, just you can see it in reality. As for quantum cascade, the problem is, and the issue is still the temperature of operation. So world record now is 200K things are world, I mean, it's 3 years old world record, and it seems that very physically it's very difficult to overcome this. In principle, people are making quantum design of materials, trying to play intercavity mixing. It means if you have very good strong infrared laser, you have 2 of very good infrared lasers, you can produce artificial material, try to mix them in this nonlinear media, and this frequency generation can appear in terahertz. It works, and at room temperature, world record is 1.5 milliwatts in the pulse mode, but room temperature tunability is 2.7 up to 3.4, I think, and not lower, because of limitations coming from the waveguide and tricky things. So in principle, they exist. In principle, technological changes overcome. Unfortunately, still no practical use for that case, for this low powers in this range. That's a little bit issue.
There is one more question from YouTube, and I have my question personal. So Jonas Bergins sends some greetings to speakers and attendees, and his question is, I'll read it. We can speculate as much as we like about what will or can be done, but where we should focus ourselves, not just as human beings, but also as a nation, so we could talk about something after 100 years.
Audrus?
Please start. I will be very short. In my opinion, so there are two answers. One answer that you have to do what you do best. It's the general rule that it takes much less effort to become perfect from very good than to become average from zero. So do whatever you do best and do even better, so that you are the only one. And second, try to look around to help other people and see whether other people can help you. This is a general rule. So always do what you do best. I mean, not try to make of yourself what you're not. So this applies also to what Gintaras and Augustinas will tell.
I have nothing to add. It's exactly what you should do. So it's like really focus on the strengths, and that's it. So.
Nothing more specific, maybe.
No, I mean, I'm usually...
More specifically about the future of our nation, Jonas asked, about where our nation should focus.
I don't know. If you look, I mean, it depends a little bit. If you look at the scientific point of view, I would say that we should go to. We have no oil. We have no diamonds. We are not in a good place. We're living in a good place. Geopolitical, not so safe, I would say. But in principle, what we have is good people here, and we had good scientific traditions. We have good engineering traditions, and I think that we should follow this way in general. But as for scientific, I'm always saying for my students that you should find yourself in science. If it happens, your achievement will be good, because if you do what you like is the best, the most good options what you can find in your activities. That's just my point. I don't know.
Like to ask, I'm very interesting, how can technologies be used against us, in the sense that all the smartphones, smartwatches, laptops tracks a lot of information about certain persons at a certain location at a certain time, and they can recognize if I am sleeping or I am running, and for example, so can it be used against us, and how it actually, what is the bad side of technologies?
We have already touched on some of them, but I think a bad side is these things we talked about, that technology in the form we have now can exploit people's weaknesses. You mentioned that. And I think we see that now. Well, actually, we don't really see it, but I think this is something that we should be very careful about. I think also that I lost my train of thoughts here. Keep on talking, someone else. Yeah.
Sorry. So you have to look at each other's lives. Look at your life. And count how many, when were the times when technology hurt you and when it helped you. So when I try to remember, I tried to, when I was, 3, tried to put some metal into the socket. And that hurt.
But you became a theoretical physicist.
No, but these are unique cases, but most of the time it really helped. I traveled, I visited my friends and so on. So if you count your own lives, there are cases when technology hurt. I mean, but mostly it helps.
I would like maybe to comment here. I don't think technology harms. I think people harm people, or people abuse people. Technology as itself, it doesn't do any harm. So you cannot draw red lines that we will develop this, we will not develop that. The question is, what will you use it for? So it's about the people, it's not about the technology. So.
Are there any more comments from the audience? Oh, we have a question here and later on there at the end.
So thank you for a very interesting discussion. Some technology makes our lives better, but do you think that in the future we might lose our privacy in order to live in a very secure community? Or can you comment a little bit on that?
I think it's kind of, directly proportional to the amount of data that you provide yourself. So if you don't provide it, then, if I can, be a friend of yours in Facebook, and if I can, I feel that I'm living like your life, then it's wrong, okay? That means you're posting too much stuff on yourself, okay? So if I can track your life, what you did yesterday by in 1 hour periods, that's wrong, okay? Then you're giving too much away. But, it's really hard to answer this question. I think it's all about how much we give away, sure. And
I have a comment on this technology stuff. I think the worst thing that technologies could do to ourselves is just shut down. Because imagine now lots of people just depending on their technologies, just people sitting in social networks, they sitting on YouTube, they go home, just open browser and do nothing except for sitting in social networks. And I think if we just disable all these, lots of people will not have what to do, and I don't know what will happen. So maybe you have something about that.
I agree that would be quite an interesting experiment. But I think one should differentiate between technology necessary for us and technology that we just have. I think, some of the prime times of my year is if I'm away and don't have Facebook for a week or something. Wonderful. It's nice to come back and so on, no problem. But I think humanity would survive without. I think the problem is more like the sort of data and surveillance that we actually depend on, like the infrastructure of the country, like how easy is it to call an ambulance? Will they know where I call from? All these data that tells about you and where you are and so on, that we don't use directly for our own interactions, but that we give away anyway. Also health data and so on. Those will be more difficult to live without, I think, nowadays. And this will only become more and more.
Do you believe that it is possible that one day such behavior of people not wanting some effects new technology give might become a real issue, an obstacle for development, or is it totally unrelated processes, totally different timescales, or something like that? What are the obstacles for the development of new technologies? Maybe it's also what Audris mentioned at the beginning, this disproportion of development in the world and this disproportion of net development in different parts of the world. Might it become an obstacle, or maybe humankind is already bored about something?
Yeah. So Vitote, this will be an eternal problem. There were these riots when the Industrial Revolution happened. There were riots in England because people said, okay, now we are not needed. Now factories are doing our job. What will we do? You have to change. It's difficult to change. And the same, you don't pay a person when you park your car, you pay with a smartphone. That person who collects money is not needed. So the change will always happen. And we don't know, so in restaurants, cooks will be replaced. Maybe people who do something else will be replaced. So change always happens, and there is eternal resistance, internal resistance to change, and it's in part natural, but in part unavoidable. And there will be always this friction. And what you have to learn to be flexible. And it's a good advice in many situations in life. Slightly be more flexible. A person who does not change its opinion or does not change anything will have difficult time surviving. Maybe, I don't know. I hope scientists will be the last to be replaced.
I have one more general question, so let's back a bit for more philosophy. So let's say what up to this moment we discussed that we can make something better, faster, smaller. For example, we started to discuss these sensors in airports or whatever. But what do you think might be something like breaking news, not like really new, not if it's like improvement of previous things, or like really making it more portable or really more powerful? What is going to be really something what impress people, not just like they can buy it for bigger price or something like that? Do you agree with this point that we don't have something really new, like, I don't know, artificial intelligence with self-development or something like that? Thank you.
I don't think I have an answer, but it's an excellent observation. I mean, it's like every science fiction movie is a mirror of the time, right? If you see a science fiction movie from the 70s, it just looks so 70s. It doesn't look like future. And this is the same thing we are to some extent doing here. Yeah, we are sitting saying we will make better sensors, more sensors, blah, blah. But I think one thing that seems to be we don't have now, and seems to be upcoming, and you can probably answer that or discuss that more. But artificial intelligence, autonomous systems that can decide things themselves. This sound, to me at least, as a non-computer expert, sounds like that could really change a lot of things, and it's perceivable that it will come. I don't have an idea about anti-gravity devices or something, but I think this is something that we don't have now that could make an impact. But I guess you can qualify it more.
No, in my opinion, there are primary technologies and secondary technologies, and we tertiary. So, as I said, designing a better airplane is not a goal in itself. I mean, what the airplane does. So, artificial intelligence or computing is secondary. I mean, the important thing is what we want. And I think the most important thing, at least the way I understand, so one crucial thing is as follows. You know that, for example, why people age, actually it's still not known, because there was these stories about that cells divide and there's this shortening of, what's this piece? And in any case, if people were healthy, they would live to 115, 116 years without pain, essentially. They would just die smoothly. And in principle, we all can live to 115 years and just slowly fade away. What happens is people acquire diseases. A lot of them die in pain. There is wars and so on and so on and so on. So something improving our health, that's, I think, is really most important. If people could really be disease-free and live till 115 years or 120, it depends on the genetics, and then just die without pain, I mean, that would be already something. I mean, you would have extra 40 years, maybe not a happy life, maybe in the end it will be kind of a dream, but kind of a dream where without pain, it's still pleasant. So that will be a breakthrough. Whereas now you have really terrible stories and discussion about euthanasia, whether to end suffering or not, and morphine is good or not. I mean, that will be all gone. So I think that would be a big breakthrough, and that will really add to happiness. And a lot of sensors and what people were discussing add to that. So artificial intelligence is just means to interpret life. But in the end, I mean, we have to design ourselves what we want from life. Also, I think important question which is not solved. So why do conflicts persist? So it's really fascinating. There was these stories, pictures on YouTube, how borders of Europe changed over years. Probably all see, and people, of course, stop on in that point where their own country is largest. But then, and you see, it comes to 2000, and you think everything stabilized. But then the occupation of Crimea, then there's Donbass, and so on and so on and so on. So conflicts persist. And one reason when conflicts persist, the population of the earth increases, and the resources are not the same, they shrink. And really, this is an unsolved problem, how we will deal with conflicts in the future, whether there is something basic in the human nature that really drives for the need for the conflicts, or it's just fighting for resources. And I think this is also a breakthrough to understanding of people, I think. Because why do conflicts persist? Whether they have to persist. I think this is important to understand. It's just thinking also about the future of humanity. But this more comes, it's too difficult. It's also social sciences and economics and so on. But I think this is unanswered.
But the technology subject in this subject is really complicated. Is it possible for technology to help avoiding conflicts?
I think so. For example, one example is the agricultural revolution. When was it? When fertilizers were invented. I mean, people were essentially hungry before that. I mean, people were hungry up to the middle of 20th century, most of the time. I mean, hunger was a general feeling, and now hunger is something you post on Instagram. Oh, it's just something like somebody said, oh, I really fast. So the problem of hunger was solved, but it created another problem that the population started to increase even more. So technology can help solve conflicts. I mean, people don't fight over food, at least in Europe anymore.
But to reduce the number of conflicts?
That's a good question.
Maybe nuclear bombs did.
There is one more question from YouTube. So Mindaugas Gicevičius is asking, should scientists work on developing technology for defense and military purpose? If so, what conflicts of ethics they might face and how should they cope with them?
I mean, it's. I think it's never a question of should or should not. It's up to you. If you want to, you work. If you don't want, you don't have to. But there will always be people who will work on that. I mean, it's like coming back to, I don't know, 10 questions before. It's like, should we draw a red line somewhere? You can draw it. Somebody will still be doing it anyway. Because something that is forbidden is always sweeter, and you will always go for it. Always. This is the curious nature of human beings. And if you will not work on defense, somebody will. And then you will run into a problem. So it's an arms race, right? If I do it for protection, I think it's fair enough. It's legal. If I do it to attack someone, that's an ethical issue to me at least, but maybe not to someone else. So. Yeah.
And I also have the same comment. Is it possible for technology to reduce number of conflicts, or does it go hand in hand with education, for example?
Well, I do think like nuclear bombs did reduce the number of conflicts in a way that it's like more like threatening instead of using it, because everybody knows that we'll restart from bacteria at some point if we will, start using it. So it kind of, maybe it works for at least now, more than 50 years. We'll see how it goes. But I think it works in a way, just in this very primitive way. And so other than that, it's not the technology, it's the people who are using it, right?
Do we have any comments? So it looks like we are approaching the limit of questions. So I guess we would slowly drift towards the end of this event, and I would like to ask the funnier question for all of us. Could you share your imaginations of your dream technology? For example, sitting here, I started thinking about a robot that would serve at my home and would serve other robots that I currently own, like unloading the dishwasher or removing dustbin from my robot vacuum cleaner, or I don't know, moving wet clothes from clothes washer to tumble dryer and so on. So that would be my dream technology. What would be your dream technology?
Maybe parallel universe. I mean, traveling, takes a lot of time. Maybe if we would have a chance to tunnel in a parallel universe and travel in a totally different time scale, like from Vilnius to New York within 10 minutes, that will be excellent new technology, breakthrough technology with totally new, maybe a description, physical, something like that. Maybe, I don't know what this related was, anti-materials or anti-universe, I don't know. But it will be something totally new at least for me.
But then arranging meetings would be difficult. So.
But you can just ask people to come really quickly. Just to come in. Maybe there'll be new dimension.
I think it would be fun, but a mess maybe. Yeah, I don't know. I think dream technology is difficult to say because everything you dream up, oh, it would be wonderful if we didn't have to do so and so. But it comes a little bit back to, I forgot who it was who mentioned it, that actually people like to do something with their hands. Some people like to cook, and you also mentioned that it's nice to do in the weekends at least. And I think it would be a nightmare scenario if we had robots to do everything for us. We should still do the fun stuff at least. I think a dream technology for me is something that sort of allows me to get access to information that I need seamlessly. It's super annoying. I mean, I'm a little bit farsighted, so I have to put my glasses on and then go into Google and find out about what is Planck's constant. Well, I shouldn't maybe admit that I don't recall that every time by heart. But you know, stuff like that. If we could develop technology that would make, for instance, information seeking seamlessly integrated with our thinking, could be an interesting thing. It might also be scary, but I think that could be an interesting thing. It could, depending on how the rest of the world evolves, if we get like an omnipotent internet, then it could actually be a little bit scary if everybody knows everything. Then what is there to learn? I mean, that would probably harm creativity in some way. But nevertheless, that's one thing I think that would be, without thinking too much about it, it would be cool to have. Yeah, maybe a little bit more.
Dream technology. What would be your dream technology? That's the last question to sum up the discussion.
We already make dream technology. My dream is that everybody uses it, right? So and I make a lot of money. That's what business is about, right? I'm just joking.
I always dreamt of one technology that would never come true. My answer is in two parts. One is a kind of funny part, but actually, if you've been to the west of the United States, Utah and then California and Nevada, I mean, there are huge areas of desert, which in winter or in autumn, it's sun-drenched deserts. So imagine if you live in our part of the world where December, November, and January, and you could have, and it's a huge area, you have a small house where you could teleport for just a couple of hours each weekend, right? And it's so nice. I mean, they're so empty, and you get a little bit of sun, and you teleport back, and you're back in Vilnius. So that I would really dream, and the property is very cheap because there is nothing there, but you could teleport water also. But being serious, it's just, I don't know, technology is just part of what makes you. So we have a very short period of time on the earth. And what you want to really feel your life, to live your life to the fullest, to really understand, to feel that you lived on this earth. And technology can help in many ways. I mean, that could not happen before. For example, my grandmother never visited America, never visited Poland, never visited anything. I mean, and now you can really read about things that are very, very far away, and you can really make you feel that you are more in this earth. You are more a citizen of the earth. So in this way, technology can help you feel full. And yeah, and the process of creating something new, even though you will not see it, I mean, it also contributes to that. Can contribute to that.
So I guess one of the take-home messages would be that we should be patient, yet we should be cautious and hope for the best. And with that, I would like to thank all the participants of this discussion. And I would like to announce that tomorrow we start at 9 with a lecture of Roll Beats titled Silicon Photonics from Transceivers to Life Science Applications. And thank you for your attention. Thank you.